So continuing on, just with some additional examples. Here we're given the measures of two angles of a triangle. They want us to find the measure of the third angle and then tell what kind of a triangle we have, whether it's acute, right, or obtuse. I've done the first example for you. Before we can determine what kind of a triangle this is, because these two angles are both acute, we need to figure out what the third angle is before we can tell what kind of triangle we have. So we added these together, 65. Subtract the 65 from 180 is 115. So we've got two acute angles and an obtuse angle. This is an obtuse triangle. We just need one obtuse angle or one right angle to get an obtuse triangle or a right triangle. So let's try this one. Hopefully you've already done this, but let me go through it real quickly. It'll be 49 plus 62 is 111 from 180. That's 69 for the last angle. What kind of angles are all of these angles? Acute. So this is an acute triangle. And then for this last one, in this section, 72 plus 18 is 90. So the last angle is 90. So this is a right triangle. Hopefully that wasn't too terribly difficult for anyone. Let's go on to the ones on the back, which are a little more difficult. When you get a problem like one of these where it asks you to find a whole lot of angles, you don't have to start in any particular place. Now, on this particular one, you can find them in alphabetical order. You can find A first, then B, then C, then D, then E, but you don't have to. Let me show you how you could do it in that order. So, to find angle A, a lot of times I tell people I can find angle A first. They're like, "Nuh-uh, you got to find angle B first." No, you really don't. But what you have to do is not look at just little bitty triangles. You got to look at bigger triangles. Look at the triangle that goes from this vertex to this vertex to this vertex. Do I know 2 out of those 3 angles? Yeah. If I know 2 out of the 3, I can find the last one. 71 and 40 added together is 111 from 180 is 69. Finding angle B should be really simple for you at this point. We've been doing this off and on since the second unit of the year. What kind of angles, somebody raise your hand and tell me please, what kind of angles are the B and this 133? Still waiting on hands somewhere. Oh, look, there's a hand back there. Yeah, they're a linear pair. And so someone else, if you'll raise your hand and tell me please, how are they related to each other? Yes, ma'am. They're supplementary, exactly right. So we'll take 180 minus 133, and that's 47 degrees. All right, now I can find angle C. There are 2 different ways to find angle C. There's the fast way and there's the slow way. I personally prefer the fast way because, well, I'm a mathematician, and mathematicians are, depending on your viewpoint, either extremely lazy or really efficient. C is an exterior angle to this triangle right here. The exterior angle is equal to the sum of the two remote interiors. All I've got to do to find C is add 69 and 47. It's 116 degrees. For this angle that's marked with a D, I can find it by noticing that D and 47 are the remote interior angles to this angle that's 140. That's an exterior angle. I know the exterior angle is equal to the sum of the two remote interiors. So I'll just take 140 minus 47, and that's 93 degrees for D. So far on this, I didn't have to find any extra angles. If you find extra angles, don't worry about it. It's not a big deal. To find E, I'm going to have to find some extra angles. I'm not going to be able to do this just by, find one angle. Well, let's see. If B is 47, this angle right here is 47. That should be helpful because it's in the same triangle as E is. And if this angle is 93, so is its vertical angle. Do things with vertical angles and linear pairs because those are pretty simple for you at this point. So then 40 plus 93 is 133. This angle is 133. And it is an exterior angle to this triangle right here. And I know the exterior angle is equal to the sum of the two remote interiors. So I'll take 133 minus 47, and that's 86 for E. Again, if you get stuck on one of these, just start finding the easy angles. And then see if you can get something from there. And I think, as I pointed out, exterior angles always are faster and easier to find than the interior angles. All right, let's take a look at this diagram. And let's see if we can find the angles. For angle M, we could do the angles of the triangle add up to 180. But what do we know about the two acute angles in a right triangle? What do you know about M and this 60?
They add up to 90.
Exactly right, Stetson. They add up to be equal to 90. That's true in any right triangle. So all I have to do is do 90 minus 60 is 30, and this angle is 30 degrees. I can do the same thing down here on this right triangle. I have the acute angle. All I have to do is 90 minus 40 is 50 to find that this angle is 50. And its vertical angle, N, is also 50 then. All right, let's see what we can do here. Trying to find P. I need to get something. Oh, so this is 30. So its vertical angle is also 30. I could do the angles of the triangle, but since I have the exterior angle, that's almost always easier. The exterior angle is equal to the sum of its two remote interior angles. That's the two angles inside the triangle that are not right next to it. So I'll take 112 minus 30 is 82, and that gives me angle P. I want to find angle Q. I've only got one angle inside that triangle, but I can do vertical angles right here. That's pretty easy. And then the angles of this triangle have to add up to 180. 82 plus 70 is 152, so this exterior angle is 152. Not that you really need to write that down, but it's true. And then angle Q, we can do 180 minus 152. And that's 28. And this is where some people get stuck on this problem. They think that there's not enough information to find S, T, R, and U. In actuality, you can find those, but you can't do it just by looking at the little bitty triangles. You're going to have to kind of take a step back and look at bigger triangles. Specifically, to find S, I'm going to look at this triangle. Because for that triangle, S is an exterior angle. And the exterior angle is equal to the sum of its two remote interiors. All I've got to do is add the 50 and the 28. That's 78 degrees for S. For angle T, well, let's see. I could look at this big triangle, but I've only got one angle in that one, so that's not particularly helpful. But this triangle that's right here next to the T, if that's 112, the linear pair with that, 180 minus 112, 68 degrees. And then adding those two together, 50 plus 68, we get 118, and that's angle T. The exterior angle is equal to the sum of its two remote interior angles. So let's see. I can find either R or U, it doesn't matter. If this is 78, so is this. Those are vertical angles. Vertical angles are always the same. I can find the exterior angle, 70 plus 78 is 148 for this angle right here. And it and R are a linear pair. 180 minus 148 is 32. And let's see. T is an exterior angle to this triangle. So if I do 118 minus 78, that's 40 for the other remote interior angle, which means this angle is 40 because vertical angles are always the same. And then angle U, I'll just take 90 minus 40 because the two acute angles in a right triangle have to add up to 90. These tend to be a little bit messy, and just so you know, in all honesty, a question like that one, I would not put it on the test. I might put a diagram like that and ask you a couple of things, but I won't ask you 6 or 7, and here's the reason. If you mess up one at the very beginning, and then base your other answers off of that, everything else after that's going to be wrong. So although these make great homework problems, great practice problems, they're not necessarily good test or quiz problems. Now, I could give you that same diagram and give you a couple of things and ask you for 2 or 3 angles, but I'm not going to ask you for 7 angles. Again, because sometimes you miss one and it just all falls down from there. And I don't want one mistake to cause you to miss that many. All right, I've got a worksheet for you.